Assalamualaikum warahmatullahi wabarakatuh. I want to introduce myself. My name is Aco Wahyudi Effendi. I'm from Balikpapan. I want to present my journal. The title is Behavior of Rail Ballast Layer Using Mortar Form with Lisa Finite Element Analysis. According Mr. Kabatz, in railroad development, geosynthetic can be introduced inside or under a layer of stabilizer. Mr. Young, the use of mortar foam has become one of the trend in construction section in replace the top layer of foundation as an excellent alternative. Mortar foam has a low thickness and great useful, which has been generally utilized in the development application. For the research, conducted a comparative analysis on railroad ballast by using a substitute for conventional railroad ballast material is granular material with specification. And about technique recruitment for railway by using mortar foam is a review about the stresses and the value of deformation in ballast, granular material, and mortar foam material. For this research method, in this study, the author will make typical model of railroad construction using conventional material, namely the granular material and mortar foam material. The ballast modeling will use finite element analysis with Lisa to perform model analysis on the two railroad ballast material, granular and mortar foam material. For ballast railroad, we use two material. The first is granular. We get from railroad standard of Indonesia, maximum average compare strength 1000 kg at centimeter square. And mortar foam we use Q2000 MPa and subballast using 800 MPa kPa. This is a typical of railroad. As for the cross section of the railroad track using railroad cross section with width of 1435 millimeter with road class type 1. That maximum speed is 120 km/h. With the following geometry parameter. This is from standard of railroad Indonesia for cross section with 1435 milli. We use finite element is Lisa finite element analysis. This is recent program. This is like ANSYS, Abacus, and another finite element methods software. For result and discussion in this study, research compare the stress of occur in railroad construction with ballast type using granular and mortar foam material. This is table of material property. We use 6 material. The first is steel for rail. The second is concrete FG prime 45 MPa for sliver, and 3 until 6 is ballast and sub-ballast material. We use two material, granular material, with sub-ballast is soil, plus clay, and second is ballast with mortar foam. For ballast we using mortar foam Q 2000 kPa, and sub ballast use mortar foam 800 kPa. We have a Young modulus, density, and point ratio. This is a correlation with geotechnical code. This is a stress behavior of a sweet granular. For load, we use RM21 rail load standard, plain load scheme, 20 tons. Work wide rail surface is 74.3 millimeter. Load evenly distributed on the rail surface is 2691.79 Newton and millimeter. The bearing material from the ballast track use concrete material with FC prime 45 MPa in accordance with the minimum quality proportional provision for load sliver after being given load. Then the value of deformation occur the ballast position is 86.1 millimeter is small from the record is 100 millimeter, as we can to see this figure. This is deformation is 86.1. This is for this figure is deformation in sub ballast. We have deformation is 52.02 millimeter, still small than the deformation that occur ballast, and the specification condition is 100 millimeter. This is stress behavior in ballast with granular. And the sub-ballast position with selected embankment soil stress occur is 9.95 Newton and millimeter square. In the rail load section, stress occur when the load interact with the rail surface with 1071.6 Newton and millimeter square. With small, the minimum tensile strength requirement is 1175 Newton and millimeter square, while the stress that occur in the rail sleeper is acting 0.53 Newton and millimeter square, where the capacity of concrete is 0.6 FC prime, so be 27 Newton and millimeter square, which is still greater than the stress that occur in the railroad sleeper. So this konstruksi be safe. This is a still behavior of ballast with mortar foam. In the ballast and sub-ballast material, mortar foam material using the frame capacity, where ballast user mortar foam with Q 200 2000 kPa, and for sub-ballast using mortar pump Q 800 kPa, and their stress when the load applied to the rail surface according the granular material which that load. The stress nominal that occur is ballast layer is this is deformation. Deformation is 0.0122 millimeter, while deformation occur in subballast layer is 0.0124 millimeter. So small with granular material. While the stress occur in the two ballast layer, in ballast layer is stress 2,951 Newton and millimeter square, with smaller than the result ballast layer with granular material, which is 9.95 Newton and millimeter square, while in the ballast layer and sub-ballast stress occur 7.08 Newton and millimeter square, where the result is smaller than the result of sub-ballast stress with granular material, which is 9.95 Newton and millimeter square. While the stress on the rail shape of the railroad with stress 800 4.685 Newton and millimeter square, where the result is smaller than the rail stress on ballast with granular material. This result can be seen this figure, while the stress on the railroad sliver become 0.72 Newton and millimeter square is smaller than the stress that occur in bearing with granular material. For conclusion is from the result analysis of this study, it was found that there was an increase in the ability of ballast with mortar foam material compared to granular material, deformation in stress the occur, and deformation in the value of deformation in railroad construction, providing an option for using conventional ballast replacement material. This research need to be continued to conducting experimental tests to provide information and validation the result of numerical tests, especially regarding load option, type of typical rail, and some very broad option to be re-examined. Okay, thank you for uh, this presentation. Uh, Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.